In this video, we're going to learn about the activity series. Now, you may recall learning about reactivity in the periodic trends unit. Reactivity and activity are two different things, and I just want to clarify that before going on. Reactivity, you may recall the most reactive metals are low and to the left of the periodic table, and the most reactive nonmetals are further to the right and up. And what you may recall seeing is demos where alkali metals, group 1 metals, reacted with water, lithium bubbled reacting with water, sodium further down in group 1, it bubbled a bit more vigorously. With potassium, it may have caught fire. Rubidium and cesium, you'd actually see explosions when they're added to water. And reactivity will tell us about how vigorously a reaction will occur, and that's based on rate of reaction, how fast it occurs, speed, if you will, which is kinetics, a later unit in this course. Activity is different. Activity will tell us more about whether an element will react with an ion, and it essentially is saying what's more stable. We'll explain this with an example in a moment. But I do want to point out that there is a difference between activity and reactivity, although in many cases, if you're comparing two elements, the one that is more reactive may also be more active. It's often the case. It's just not perfectly so always. And I wanted to explain why. When we look at the activity series, you can see that lithium is actually the most active. And I like this chart in most ways, but I want to clarify, it's not reactive, it's active. So for the activity series of metals, the most active metal is lithium. The second most will be rubidium, the third most potassium. And you may be aware, if you look at the periodic table, lithium is actually the highest metal among the alkali metals. And then rubidium is one of the lower ones. Potassium is in between them. Barium is group 2. So the order here is something that I'm not expecting you to memorize. It's certainly not something that you can tell just from the periodic table. We do find that gold and platinum and palladium, they are very non-active metals. It's very hard to get them to react with other metals and acids, for example. With nonmetals, we find that fluorine is, in addition to being the most reactive, it's also the most active, and then chlorine, and then oxygen, which is group 6, and then bromine, which is back to group 7, iodine, which is also group 7, sulfur, now we're back to group 6. See, it's hard to really just tell looking at the periodic table, but if you have this chart, it can be useful to you. So what does this all mean anyway? What this means is that if we take barium metal, and react that with beryllium oxide, we will get a reaction. We will get a single replacement reaction of this element, barium, replacing the metal in the compound beryllium. We will get barium oxide plus beryllium metal. And this is a simple example because barium and beryllium are both group 2. So barium is positive 2, oxide is negative 2. Okay, beryllium is positive 2 to begin with. Great, we're good. Now, how do I know that this will occur? Well, I know that barium is one of the most active metals. The only more active metals are potassium, rubidium, and lithium. Beryllium is a bit further down. It is less active. So because beryllium is lower on the activity series, it is capable of being displaced by the barium. On the contrary, if I tried to get this reaction to go, where beryllium would be replacing the barium that has already been oxidized to the positive 2 state, remember the beryllium is neutral, this isn't going to happen because barium is very comfortable in the positive 2 state, and beryllium is not active enough to displace the barium. So I will say no reaction. I want to point out, by the way, that if you're looking at this, ultimately this reaction would be where a neutral beryllium atom would be giving 2 electrons to the barium, which apparently can't happen. But in this case, a neutral barium atom is giving 2 electrons to the beryllium and changing it from a positive 2 charged beryllium to a neutral beryllium. That is okay because the electrons are more stable when with the beryllium than they are with the barium. That's the driving force here. And how do we know it? Well, we know it because the activity series tells us that barium is more likely to be in that oxidized state than beryllium. So moving on, let's take an example here. Strontium metal is added to a solution of zinc chloride. Will a chemical reaction occur, and how do you know? Let's see, we have Sr, which is solid. And actually, I should do the chemical equation below. We have Sr, which is solid, reacting with zinc chloride. Well, zinc only can ever be positive 2, and chlorine is negative 1. And so we have ZnCl2, and this will be aqueous. And the question is, will this react to form anything? I have to compare my strontium and my zinc. What is the most active? If the strontium is more active than zinc, it will react and displace the zinc. But if zinc is more active than strontium, then the zinc won't be displaced. I look here, I see that strontium is pretty high on the activity series. Zinc is quite a bit lower. And so I know that a chemical reaction will occur because Sr is more reactive. Sorry, why did I say reactive? It's more active than zinc. And so what happens is we get zinc metal in this single replacement reaction plus strontium chloride, SrCl2. I know strontium chloride because I know the strontium is positive 2, the chloride is negative 1, and that's why I need the 2 chlorides, and this will be aqueous. So the thing to know here is that if I'm proposing to you, oh, here's a potential single replacement reaction, write the product, you have to be wary of the fact that maybe there won't be a reaction at all. If I mix these two things together, maybe there won't be a reaction. And actually, common thing is that metals, when you throw them into acids, they'll react. Well, not all metals will, actually. Platinum, gold, they don't react with acids. But tin, nickel, magnesium, aluminum, and of course the alkali metals and the alkaline earths, they'll react with acids. And actually, most of the group 1 and group 2s will react with even water, which is a much more mild reagent. So I hope this video has been helpful. Let me know if you have any questions or feedback in the comment section below. Thank you very much.